Hello 10 set 1. So sorry I can't be there with you today. There are reasons that I can't be there. So if we can crack on as usual, Dydd Gwener, it's the 20th of Tachwedd, energy transfer and efficiency. Your keywords, Sankey, conservation and efficient. And then if you can complete these 4 questions with a challenge at the bottom. So question 1, I only allow current to flow in one direction. What am I? Question 2, I measure the voltage. What am I? Question 3, I am the circuit, or I am a circuit that the resistance increases as the more components you add. So as you add more components to this type of circuit, the resistance will increase. Okay, that's an awkward sentence there. Question 4, I am used in security lights. What am I? And then your challenge, draw a standard. Sorry, that's missing there. That should be a standard. Let me get my pencil out. Standard test circuit for a fixed resistor and give a quick method on how to use it. Okay, so you can press pause now, look at the questions, and then show your teacher. Then we'll press play for the answers. Okay then, so I only allow current to flow in one direction. That is a diode and it looks like this. Okay, straight through. I measure the voltage. That is a voltmeter. If you're getting these wrong now, alarm bell should be ringing. I am a circuit that the resistance increases the more components you add. This is a series because if I keep adding components like a 3 ohms there and then maybe a 6 ohms, they're all going to add up, so they're all going to increase the resistance there. I'm using security lights. That's an LDR, light dependent resistor. As you increase the light intensity, the resistance decreases. Draw a standard test circuit. That's what the standard test circuit looks like. Oh, I've forgotten the voltmeter. So the voltmeter would go across there. But this is a fixed resistor. And then give a method. So I'm not going to write this out, but step 1 would be to set the variable resistor to maximum setting, so it doesn't allow any current or voltage through. And then your step 2 would be to measure the current with an ammeter, measure the voltage with a voltmeter. And then your step 3 would be to record the values. Step 4 might be to adjust the variable resistor then incrementally to suit the voltage, and then so on. And then that last step would be flip the battery to get a set of negative results as well. Okay. I'm going to push on now to the lesson. Oh, let me scroll up there. So there's types of energy. So can you get this down in your books? There's 8 types of energy, and I remember it by English Kids Hate Learning GCSE. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8. And each one of these then will represent a type of energy. Now, you're not going to be tested on this. Okay, the question's not going to be like list the 8 types of energy. But you need to know them to be able to give the energy transfers and then to be able to calculate efficiency. And that's what we're going to be doing in today's lesson. So electricity, English, kids, kinetic, which is another word for movement, science word for movement. Hate, heat, also known as thermal. Learning, light, G, gravity, C, chemical, S, sound, E, elastic. And then we've got, so press pause if you need to, get that down. And then we've got energy transfer. So I've got a quick hairdryer here. I'm just going to move this down a little. So energy transfer in a hairdryer, or what you need to get it to work, is going to be plugged into the mains electricity. So electrical energy. And that's going to turn into 2, maybe 3 types of energy. The output energy, some of it's useful, some of it's wasted. As you can see here, I've split it into 2 categories. So heat and kinetic, because there's a fan there, it needs to move, it needs to blow your hair. So your kinetic is useful, your heat is useful because it's going to dry your hair. What's the wasted energy? Is sound. We don't need to hear the sound, but it produces a lot of sound and it's wasted energy there. And then, I'm just going to move that to the side. Your typical Sankey diagram is going to look something along the lines of this. And now, I used someone's book before, so what I'd like you to do is to get... let's have a look what's used there. No. So I'm just checking now. I need you to get this Sankey diagram written in your book, kind of like this, because it's going to represent now the energy transfer in that hairdryer. So I've got the, again, press pause by all means, but I've got the input energy of 500 joules there. That's going in. If it continues across like this, then it's useful energy. I got 300 joules there as heat and kinetic, and wasted energy goes down. And again, you've got 200 joules. 200 plus 300 equals 500. Sometimes you'll have to fill in one of these. The other thing I'd say here, there's 1, 2, 3, 4, 5. Well, it should have been 5 lines there, okay, but there's 6. But then each line would have represented 100 joules. Do you see what I mean? So this is kind of to scale. So you can see 3 lines have been used for 300 joules, and then the width of the arrow is the important bit. It doesn't matter how much you come down, how far you come down here, it's just the width of this arrow now, which is around about 2 lines. Okay, but again, if you're not understanding this, we'll do some work on this again. But this value here, so this length adds up to this width and this width. If you was to turn this on its side, then it would be the same thickness as this, if you know what I mean. Then we'll do efficiency. There's the efficiency equation. Okay, it's percentage equals useful over total times 100. This is also going to be found in the front of your exam papers. There it is, look, efficiency, energy over total times 100. And then I think that was it for this lesson then. I think that was probably as far as we got with that class. So at least you're up to date now, set 1, with everything else. And then I guess the last thing to do is to calculate. Ah, there it is. I just found it now. So if I can grab that, there it is. So at the bottom there, percentage equals 300. The 300, which is there, the useful energy, okay, going to this way, over the total going in, which is 500. So that's what we've got down the bottom there. I'll just zoom in on it. So 300 over 500 equals 60% once you times it by 100, okay? So thanks for listening. I know it's been a quick video, but at least you got something in your books now that I wanted you to get. So I'm going to do my best to upload this to YouTube before your lesson starts.